Good day everyone, today we will be discussing the integral word problems. Integrals in math are used to find many useful quantities such as area, volume, displacement, etc. When we speak about integrals, it is related to usually definite integrals. The indefinite integrals are used for antiderivatives. Integrals are the values of the function found by the process of integration. The process of getting f of x from f prime of x is called integration. Integrals assign numbers to functions in a way that describes displacement and motion problems, and so on that arise by combining all the small data. Given the derivative of f, of the function of f, we can determine the function of f. Function of f is called antiderivative or integral of f prime.
Another example that requires the application of integrals in order to solve real-life scenarios. Assume a population of fish grows exponentially. A pond is stocked initially with 500 fish. After 6 months, there are 1,000 fish in the pond. The owner will allow his friends and neighbors to fish on his pond after the fish population reaches 10,000. When will the owner's friends be allowed to fish? After analyzing the given scenario, it is now the time to show the solution of how this problem will be solved using the application of integrals. We know it takes the population of fish 6 months to double in size, so if t represents time in months, by doubling time formula, we have 6 is equal to integrals of 2 over k. Then, k is equal to integrals of 2 times 6. Thus, the population is given by y is equal to 500e times integrals of 2 over 6 times t. To figure out when the population reaches 10,000 fish, we must solve the following equation. 10,000 is equal to 500e integrals of 2 over 6 times the t. 20 is equal e integrals of 2 over 6 times t. Integral of 20 is equal to integral of 2 over 6 times t. For now, t is equal to 6, integral of 20 over integral of 2. And with that, the final equal is 25.93. In conclusion of this given scenario, the owner's friends have to wait 25.3 months or a little more than 2 years to finally fish in the pond.
A 25-year-old student is offered an opportunity to invest some money in a retirement account that pays 5 annual interest compounded continuously. How much does the student need to invest today to have 1 million peso when she retires at age 65? What if she could earn 6 annual interest compounded continuously instead? For our solution, we have 1 million is equals to PE raised to 0.05 times 40. Therefore, the value of P is equivalent to 135,335.28. She must invest 135,335.28 at 5 interest. If instead, she is able to earn 6, then the equation becomes 1 million is equals to PE raised to 0.06 times 40. Therefore, the value of P is equivalent to 90,717.95. In this case, she needs to invest only 90,717.95 pesos. This is roughly 2/3 the amount she needs to invest at 5. The fact that the interest is compounded continuously greatly magnifies the effect of one increase in interest rate.
One of the most common applications of an exponential decade model is carbon dating. Carbon-14 decays at a regular and consistent exponential rate. Therefore, if we know how much carbon was originally present in an object and how much carbon remains, we can determine the age of the object. The half-life of carbon-14 is approximately 5,730 years, meaning after that many years, half the materials has converted from the original carbon-14 to the new non-radioactive nitrogen-14. If we have 100 grams carbon-14 today, how much is left in 50 years? If an artifact that originally contained 100 grams of carbon now contains 10 grams of carbon, how old is it? Round the answer to the nearest 100 years. So in our solution, we have 5,730 equals to integrals 2 over 5,730. So the model says, so the answer to this is 99.40. Therefore, in 50 years, 99.40 grams of carbon-14 remains. To determine the age of the artifact, we must solve 10 equals to 100e raised to negative integrals 2 over 5,730 times 10. To determine the age of the artifact, we must solve 10 equals to 100e raised to negative integrals 2 over 5,730 times time. So 1 over 10 equals to e raised to negative integrals 2 over 5,730 times t is equals to 19,035. Therefore, the artifact is about 19,000 years old.
Suppose a population of fruit flies increases at a rate of g of t equals to 2e raised to 0.02t in flies per day. If the initial population of fruit flies is 100 flies, how many flies are in the population after 10 days? So next is to calculate the population after 10 days by substituting t equals 10 into the growth rate function. G of t is equals to 100e raised to 0.02 times 10 equals to 100e raised to 0.2 equals to 100 times 1.22. The final answer is g of 10 equals to 122.14. But since the population cannot be a fraction of a fly, we round the result to the nearest whole number, which gives us 122 flies.
According to experienced baristas, the optimal temperature to serve coffee is between 155 degrees Fahrenheit and 175 degrees Fahrenheit. Suppose coffee is brewed at a temperature of 200 degrees Fahrenheit, and after 2 minutes in a 70 degrees Fahrenheit room, it has cooled to 180 degrees Fahrenheit. When is the coffee first cool enough to serve? When is the coffee too cold to serve? For our solution, T is equals to T0 minus TA times E raised to negative KT plus TA. 180 is equals to 200 minus 70 times e raised to negative k times 2 plus 70. 110 is equals to 130e raised to negative 2k. 11 over 13 is equals to e raised to negative 2k. In 11 over 13 is equals to negative 2k. In 11 minus in 13 is equals to negative 2k. K is equals to in 13 minus in 11 divided by 2. Then the model is t is equals to 30. Then the model is t is equals to 130e raised to in 11 minus in 13 over 2 times t plus 70. The coffee reaches 175 degrees Fahrenheit when 175 is equals to 130e raised to in 11 minus in 13 over 2 times t plus 70. 105 is equals to 130e raised to in 11 minus in 13 over t times t. 21 over 26 is equals to e raised to in 11 minus in 13 over 2 times t. In 21 over 26 is equals to in 11 minus in 13 divided by 2 times t. In 21 minus in 26 is equals to in 11 minus in 13 divided by 2 times t. T is equals to 2 times in 21 minus in 26 divided by in 11 minus in 13. It is equal to 2.56. In conclusion, the coffee can be served about 2.5 minutes after it is brewed. The coffee reaches 155 degrees Fahrenheit at 155 is equals to 130e raised to in 11 minus in 13 over 2 times t plus 70. 85 is equals to 130e raised to in 11 minus in 13 times t. 17 over 26 is equals to e raised to in 11 minus in 13 times t. In 17 minus in 26 is equals to in 11 minus in 13 divided by 2 times t. T is equals to 2 times in 17 minus in 26 divided by in 11 minus in 13. It is equals to 5.09. Therefore, the coffee is too cold to be served about 5 minutes after it is brewed.
Now that my group members have finished explaining their integral world problems, you have a more deeper understanding about this topic. Integral calculus is incredibly important in the field of mathematics. It is a fundamental concept that allows mathematics and scientists to solve problems related to area, volume, and many other applications in mathematics and physics. Integral calculus is also crucial in the fields such as engineering, economics, and computer science. It plays as a key role in understanding and modeling real-world phenomena, making it an essential tool for various disciplines.